solving equations with fractions, very similar to how we did this with integers and decimals. You're going to see a little extra thing that we do with fractions that goes back to the fraction rules you learned last unit about multiplying and dividing fractions. There it is again. Ultimate goal when solving any equation, if it's these small equations we're doing 7th grade math or the crazy equation you're doing in Algebra 3, you're going to isolate the variable. How do we do this? We undo what's happening to the variable. And in 7th grade world, we're dealing with addition and subtraction undoing each other, multiplication and division undoing each other. Next year, you're going to see how square roots and squaring a number are inverses of each other, or a cubed root and a cube of a number are inverses of each other. The multiplicative inverse property. This should sound familiar from just a few lessons ago when you were dividing fractions. If you remember about dividing fractions, we said you're really just multiplying by its reciprocal. This is where we did keep it, change it, flip it. So a reminder of the multiplicative inverse property. It says that a product, meaning you multiply, of a number and its reciprocal or multiplicative inverse is 1. So if you have 4 over 5 and you multiply it by its reciprocal 5 over 4, multiply across, you get 20 over 20, which is 1. Or the whole number 3, its reciprocal is 1/3. You multiply across, you get 3 over 3, which is 1. So we remember what a multiplicative inverse or a reciprocal is called. Here's how it applies to equations. If you start with the equation 2 over 3x equals 5, you know you're going to undo what's happening to the variable, which it's being multiplied. And we know to undo multiplying, we're going to divide by 2/3. But we're going to go ahead and connect that with what we know about dividing fractions. To divide that fraction 2/3, I'm really multiplying by its reciprocal. So I can go ahead and skip to that step and show that I'm going to multiply by 3 over 2, the reciprocal on both sides. If you were to multiply across, you're going to get 6 over 6. Or you could cross simplify, you're going to get 1 over 1. And we know that either 6 over 6, 1 over 1, any way you do it, it's basically the whole number 1. The whole number 1 in front of x is just x. That's what causes these to cancel out. And it just comes down as the whole number 1x, which we know is just x. On the right side, I put 5 over 1. I multiply across. 5 times 3 is 15. And 1 times 2 is 2. And the improper fraction 15 over 2 can simplify to 7 1/2. Okay, so let's see some examples. 2 over 3x equals 4 over 5. Like before, you're wanting to undo what's happening to x. It's being multiplied by 2/3. So I'm going to undo multiplying by 2/3 by dividing by 2/3. What's starting to happen, hopefully, in your brain is you're saying, well, I'm really not ever going to divide. I'm really just going to be multiplying. I'm multiplying this side by the reciprocal, 3 over 2, and I do the same thing, property of equality, to this side. You'll see the difference in multiplying and dividing. To make those numbers cancel out, the difference between multiplying, dividing, and adding and subtracting. With adding and subtracting, you want it to make 0, and that's what makes it disappear. In multiplying and dividing, you want to make that coefficient 1. So 3 over 2 times 2 over 3 cancels. X comes down, x equals, and I'm going to multiply 4 times 3, which is 12, 5 times 2, which is 10. You reduce that, and you're going to get 1 and 2 over 10, which is 1 1/5. Many of you probably cross-simplified up here, and you saw that the 4 and the 2 could reduce. That still applies, and that would go down to 1, and you would have gotten then 6 over 5, which would have brought you to 1 1/5. Completely okay to do it that way. As you can see, you still got the correct answer. For the next example, we are adding fractions, and if you'll recall to your fraction rules, To add fractions, you have to get a common denominator, and the same with subtracting fractions. If you struggle to remember what is it that I do with each operation, with integers, with decimals, with fractions, keep those organizers out that we've made and use those as a reference. I'm going to undo adding 3/8 by subtracting 3/8 on both sides. 3/8 minus 3/8 is 0, so that simplifies, and P comes down. So I'm subtracting -1/6 minus 3/8, and I have to make sure that these have a common denominator. That least common denominator is going to be 24. So to go from 6 to 24, I multiply by 4. So I multiply up here by 4. 1 times 4 is 4. And then down here, to go from 8 to 24, I'm multiplying by 3. So I multiply 3 times 3, and I get 9. Now don't forget your integers. I have a negative minus this. Different ways you could think about it. You could think of it as adding a negative. That's the same thing as subtracting. You could keep, change, change. Either way, you're combining the two negatives. When I have two negatives that I'm adding, I'm finding the sum. They have the same sign, so I find the sum. I'm going to go ahead and bring down my negative sign so that I don't forget it. So P equals negative, and then we're going to figure it out. I'm going to add my numerators. 4 plus 9 is 13. 13 over 24, and that is reduced. I cannot reduce that anymore. So P equals negative 13 over 24. Here's two for you to practice. Pause the video, you try them, and then we'll compare. Okay, with practice A, J plus 5 over 8 equals 11 over 16. You're going to undo adding by subtracting 5 over 8 on both sides. You can see over here where I made it a common denominator, 5 over 8 is renamed as 10 over 16. I subtract 11 minus 10, and I get 1 over 16. So J equals 1 over 16. I hope somebody along the way in your math career has explained to you or showed you the little trick that if a 1 is on top of a fraction, you know it's reduced. 1's on top tell you it's reduced, and also if numbers are consecutive, such as 2 over 3, 6 over 7, 9 over 10. You know for sure that they are reduced then. Looking over here at practice B, 3y equals 6 over 7. You might have done this a little different than I did. Your brain said, okay, I'm multiplying by 3. Y is multiplied by 3, so I'm going to undo by dividing by 3, and you drew a line underneath, and that's completely okay. But what happened is when you got over here to divide 6 over 7 by 3, you said, to divide by 3, I keep it, I change it, I flip it, so I'm multiplying 6 over 7 times 1 over 3. What I've done is I have skipped that step. When you are trying to make 3 a 1, that's really what we're trying to do. So I'm asking myself, what can I multiply 3 by to get 1? It's 1/3. Or I'm dividing by 3. That's the same thing as multiplying by a third. Do that on both sides. They cancel over here. Y comes down. Multiply 6 times 1, you get 6. 7 times 3, you get 21, which reduces. I break it down by 3's, and I get 2 over 7. You may have cross-simplified up here. And that became 2, and that became 1. 2 times 1 is 2. 7 times 1 is 7. And you went ahead and got 2 over 7 that way.